Section 4.6, triangle congruence, CPCTC. Very long abbreviation for some very cool things that we're going to look at. First, this warm-up, take a moment to pause the video, look at those 3 examples. Out of your 5 options, side, 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 angle, 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 side, and HL, how could you get those 3 triangles to be congruent? Take a moment, check my completed notes, and then start the video up again. So, that very long abbreviation, CPCTC. It's an abbreviation for corresponding, C, parts, P, of, forget about it, congruent, C, triangles, T, are congruent, C. Corresponding parts of congruent triangles are congruent. It is used as a justification after, I cannot stress this enough, after you have proven 2 triangles congruent with one of those 6 options we've been talking about. This does not prove that 2 triangles are congruent. You use it after you have proven 2 triangles are congruent. Because it says corresponding parts of congruent triangles. So it's assuming the triangles are already congruent. How could you use it if you don't know they're already congruent? So you have to use it after. Now what it does, it allows you to use that definition of congruent to talk about corresponding parts that you may not have addressed in your proof. So let's say you use side, side, side to prove 2 triangles are congruent. CPCTC, then, after you've proven them congruent, then it allows you to talk about any pair of corresponding angles. So let me show you how this works. So let's go ahead and get our 2-column table going on. We have YW bisecting XZ. Then we also have XY, I'm running out of room, congruent to YZ. That is our given information. Okay, so let's go ahead and use these givens. I'm going to start by marking up the diagram. XY is congruent to YZ. There we go. So I've used that given. Now let's use the fact that we have some bisecting information. Line segment YW is bisecting XZ. We've seen this before. That would mean that XW is congruent to ZW by the definition of a segment bisector. I would hope at this point, if you've been engaging with these proofs and looking at references and writing things down, that a lot of these moves should start becoming a little automatic. You've seen them enough times. It's kind of like in algebra. When you have x plus 5 equals 7, you've seen it enough where you say, hey, plus, I have to do a minus. You see, hey, 2 segments being bisected, got to use the definition of a segment bisector. So, used up that given. Let's mark up the diagram. I've used up all my givens. Now I got to go off on my own and try something new. Okay, so we look at this and we want to get another pair of congruent sides or some congruent angles. Well, we've seen this a couple of times where these 2 triangles are sharing YW. So we can say that YW is congruent to itself because when YW is a part of the triangle on the left and a part of the triangle on the right, it does not change. It's the same segment. So the reflexive property says it's congruent to itself, which we now have 3 pairs of congruent sides. So triangle XYW is congruent to triangle ZYW by side, side, side. 3 pairs of congruent corresponding sides. Now I'm not done. Look at the proof statement. We want those angles congruent. Angle XYW and ZYW. Well, we know the triangles are congruent. Congruent means identical in all ways. So the corresponding angles are going to be congruent to each other as well. That's the definition of congruency. Now, we already proved that the triangles are congruent. That means that any corresponding parts of those congruent triangles are congruent to each other. Luckily, you don't have to write all those words out. We have an abbreviation. CPCTC. Notice how CPCTC comes after the triangles are congruent to each other. You need to use it after the triangles are congruent. So take a look at the other example. Check my completed notes online. Yeah.